Of numbers and logistics, we map our data within statistics. We study and analyze with interpretation, with an emphasis on organization. It all seems so darn complex, with numbers and symbols that look like checks. Fear not, for this is an easy fix, to learn the tricks of 3 and 06. Association is used to measure variables at the ordinal level to make it amiable. For equal columns and rows to be, you'll need Kendall's variant of tau b. And the opposite is true, you see. For unequal equations, you need tau c. With the process of calculation, we'll find gamma's interpretation. As this poem seems to flow, so will your knowledge of Spearman's row. Then you'll see how you fare with the logic that comes in pairs. The trick with pairs is appropriation, which will measure association. Analyzing data and assortment in the world of stats, it's all important. We're almost done, so please don't flee. We'll finalize by learning Somers D. So now, without further hesitation, let us begin our presentation. When dealing with measures of association, there are 2 common types of ordinal level variables. First, we have collapsed ordinal level variables, which include gamma, computed by subtracting the number of similar pairs from dissimilar pairs, then dividing this result by the total number of pairs. Kendall's tau b is a measure of association appropriate for 2 variables measured with collapsed ordinal scales with an equal number of rows and columns. Tau c is association appropriate for 2 variables measured with collapsed ordinal scales with an unequal number of categories. Somers D is association appropriate for 2 variables measured with collapsed ordinal scales where one variable is identified as the dependent variable. Spearman's row is a measure of association appropriate for 2 ordinally measured variables that are continuous in form. The logic of pairs: gamma, Kendall's tau b, Kendall's tau c, and Somers D. Each measures strength and the direction of association by comparing respondents, called a pair, in terms of their ranking on independent and dependent variables. This formula is used to help find pairs. N equals the total number of respondents. N times n minus 1 over 2. Pairs are divided into 5 subcategories. These are similar pairs, if the respondent with the larger value on the independent variable has the larger value on the dependent variable. Dissimilar pairs, respondent with the large value on the independent variable has the same value on the dependent variable. Tied pair on the independent variable, if the respondent have the same value on either the independent variable or both. Specifically, a pair is tied on the dependent variable, if both respondents have the same score on the dependent but not the independent variable. Tied pair on the dependent variable, a pair is tied on the independent variable, if both respondents have the same score on the dependent but not the independent variable. Tied pair on both variables. A pair is tied on both variables if both respondents have the same independent and dependent variable scores. Kendall's tau b indicates both pairs tied on the independent variable and pairs tied on the dependent variable. It is found by using the following formula. Ty is the number of pairs tied on the independent variable. It should be used when the bivariant tables have an equal number of rows and columns. Kendall's tau c. This is used when tables have an unequal number of rows and columns and is computed by using the following formula, where m is the minimum. A limitation of tau c is it can reach a maximum of 1 only when the independent variable and the dependent variable have the same number of categories. Kendall's tau b or Kendall's tau c. When choosing the appropriate formula, it is important to note that tau b is used where there are an equal number of categories in the independent and dependent variables. Tau c is used when the number of categories are not the same. Both range from -1 to +1. Somers D is used when one of the variables can be identified as the dependent variable ranging from -1 to +1 and is an asymmetrical measure. The values can be computed where y is treated as the dependent variable and x is treated as the dependent. It is found when using this formula, where y is the number of pairs tied on the dependent variable. Spearman's rho is a measure of association for ordinal variables that are continuous in form. The first cases are ranked from highest to lowest on each variable and then are manipulated to produce the final measure. It is found by using this formula: 1 minus 6 times the sum of d squared divided by n times n squared minus 1.
We will use SPSS to produce ordinal level measures of association. We will simply interpret the direction of relationships. We will be using the 2009 GSS shortened version. Our research question is, does the state of health vary by one's household income? Refer to Chapter 11, Figure 11.1 for information on recoding your variables, income and health, which are used in your bivariate table. We use percentages to look at the relationships between recoded SRH underscore Q110, which is the state of health, which is now recoded into health, and recoded INCM HSD, which is the total household income, which is now recoded into income 4. Let's re-examine the relationship and find out whether gamma, Kendall's tau C, and Sober's D can add any new information. We will use the crosstabs program for income 4 as the independent variable, which is column, and health as a dependent variable, which is row. In the crosstabs dialog, click the statistics button and request gamma, Sober's D, and Kendall's tau C. We have selected Kendall's tau C given the unequal number of categories on the independent and dependent variables. Don't forget to click the cells button and request column percentages. Click OK, and the output box should look like this. Let's look at gamma first in the symmetric measures output box. A value of negative 0.401 indicates a strong and negative relationship. You would think that the higher income, the lower the health, right? No, wrong. Look at the codes for health. A low score indicates a high level of health. The negative side of gamma is telling us that higher scores on income 4 are associated with a low score, a score of 1 or good on health. Let's look at Kendall's tau C next. A value of negative 0.104, which indicates a weak to moderate relationship. Remember, when considering the relationship between the value of ordinal level measures of association and the strength of relationship, use this chart as reference. If the value is between 0 and 0.10, the strength of relationship is weak. If it is between 0.11 and 0.3, it is moderate. And if it is greater than 0.3, it is a strong relationship. The value is much lower than gamma, as well as Sober's D reported in the directional measures output box. There are 3 values for Sober's D. Now, let's look at the symmetric version of Sober's D, which is negative 0.118. This is the type of average of the 2 asymmetrical direction versions of Sober's D. DYX, which is our health dependent, is negative 0.073, and our DXY, which is our income 4, our dependent variable, is negative 0.304. So which one do we use? Gamma? The strength of relationship is often exaggerated, so no. Therefore, Kendall's tau C or Sober's D will offer the most realistic picture of the strength of association between income and health. However, the asymmetrical Sober's D, which is negative 0.73, is likely the most appropriate measure only if one of the variables is specifically identified as a dependent variable, example, health. You now know how to compute ordinal level measures of association using SPSS.